In this example, we're asked to solve a simple trig equation. However, this time we're not using one of our special angles on the unit circle, so we're going to have to use the calculator to find these angles. So meaning this is 1/4, and that isn't the sine of any of our special angles on the unit circle. Okay, so this is going to require some using of the calculator. So let's draw a circle. So now set your calculator into mode radians, because we're looking for our angles in radians that are within the interval 0 to 2 pi that have this sine of 0.25. Okay, so let's write out our equation. Our equation, sine of x is equal to 0.25. All right, now let's think about it this way. If I want to get to this x right here, I need to undo the sine. All right, so the way to undo the sine is to take the inverse sine. So I would take the inverse sine of the sine of x. What you do to the left, you must do to the right. So this gives you an x, and we have to use our calculator to find out what the inverse sine of 0.25 is. So if I say in my calculator the inverse sine of 0.25, I'm getting a value equal to, and you can verify this on your calculator, 0.25268. All right, so keep all those digits in there. Don't round it. You could even keep more if you wanted to. All right, so let's think about our circle in terms of radians. So this is 0 radians, and this is pi radians. So in decimal form, pi is approximately 3.14. Half of pi is approximately 1.57. And 3 pi over 2 is approximately 4.71. And then back to 2 pi over here, which is 6.28. All right, so if our x value, this is our angle, when we solve trig equations, we're looking for angles, is 0.25. So that's in the first quadrant over here. It's small. All right, so our sine right there should be 0.25 at an angle theta. We're using x in this problem. X, an angle x equal to 0.25. Let's move it over a little bit. 0.25268. All right. Now, from what we know about sines, they're positive in the first and the second quadrant. So you know you're going to have another angle over here with that same amount right here. 0.25268. Okay, so when we talk about naming angles, we have to make sure we start on the initial side over here of 0. So we've named this angle starting on your initial side, ending there. Now we got to name this angle here. So starting on the initial side and going all the way over to there. So one of our angles is 0.25268. All right, and the other angle is going to be, now let's look at this carefully. If I take off this little bit off of this piece of the circle, which is pi radians, I'll have pi minus this bit right here, 0.25268. So I can type that into my calculator, pi minus 0.25268. So that's 3.14 minus 0.25268. So that's equal to approximately 2.8889 radians. All right, so there are going to be two angles that have that sine equal to 0.25 that we're looking for. In the first and the second quadrant, you will have an angle that fits the bill. Now let's try a cosine problem that doesn't involve one of our special angles. So this is also going to require a calculator, because this value, negative 0.3, is not the cosine of one of our special angles. So let's write down the problem. Cosine of x is equal to negative 0.3. So if I want to get my x out of this problem right here, I'm going to say undo the cosine by taking the cosine of cosine of x. So that'll undo that. But what you do to the left, you do to the right. All right, so I'm going to get x is equal to the inverse cosine of negative 0.3. So in mode equals radians in your calculator, you're going to input inverse cosine button negative 0.3. And you should get the value 1.8755 once you do that in the calculator. So make sure you're trying this and you agree with what I'm getting here. So now let's write our radian values in decimal form on here again so we can picture which quadrant we're in. So, all right, so I put them on there in red, and we've got an angle x here of 1.8755. Okay, so here's 1.57, here's 3.14, so it's in the second quadrant somewhere, roughly right here. So this is your angle from the initial side. Here's your initial side. So this is your angle right here, which is equal to 1.8755. All right, so if we've got a negative cosine, we know that we've also got a negative cosine in the third quadrant. All right, so down here I'm going to also have a negative cosine that'll be the same value as the angle here. Okay, so you can see that using geometric patterns, this piece right here was going to have to be the same size as this piece right here. Or if you look at it another way, this piece right here is going to have to be the same size as this piece right here in order to have that same x value here, which is our cosine, negative 0.3. So this negative 0.3 cosine is going to occur for this angle here, and it's going to occur for this angle here. All right, so now we just have to figure out, using subtraction, what that angle is from the terminal side, from the initial side. So I've got to start on the initial side now, and I've got to go all the way over to this line now and figure out what that angle is. So what I can do is I can take my whole circle, which is 2 pi, and I can subtract off this piece here, which I know is the same size as this piece here, which is 1.8755 radians. So my x for this angle here, my angle x here, let's say in green, is 2 pi radians minus that chunk 1.8755, and that'll leave me with this piece here. So full circle minus this piece here is going to leave me with this much here, which is the angle I'm looking for here. So if I subtract that off of there, I'm going to get x is equal to 4.4077 radians. So that's this one here, 4.4077 radians to this point right here. All the way from here to here is 4.4077 radians. So it's not quite at 4.71. So it's in the third quadrant. So we've got one angle here, 1.8755 radians, and one angle here, 4.4077 radians. So there's two angles that have a cosine equal to negative 0.3, which is this x value right here. All right. All right, so let's do one more of these. Let's do a tangent this time. So it says find all solutions of the tan theta is equal to negative 0.0175 on this interval negative 90 to 90. So we're talking about degrees here. Let's continue working in radians because we need a little bit more practice understanding radians and then convert to degrees in the end. So if we're talking about between negative 90 and 90, this would be 90 here, which is pi over 2 radians, which is 1.57 in decimal form. And then negative 90 is down at the bottom over here, negative 90 over here. So that would be negative 1.57 radians. So we want to find angles on that side of the circle that have a tangent equal to negative 0.0175. All right, so here's our equation. So we want to undo that tan, so we're going to say inverse tan of the tan theta will equal to inverse tan of the right-hand side. And that'll give me my angle theta. So if you type that in to your calculator in radians, you should end up with negative 0.017498. All right, so that's a small negative angle right there. So that means I'm over here somewhere at theta is equal to negative 0.017498 radians. All right, so that's a very small number right there. All right, so that means my tangent has got to be a negative number there. Okay, now our tangents are equivalent, diametrically opposed to one another. So in order to get a negative tangent, I'd have to be over here in Q2. But that's not in the range of where they're asking for your solutions. They only want them in this range over here. So we're not going to consider this angle in this problem because it asked for only your thetas in that part of the circle right here, which is from positive 90 to negative 90. All right, so we're going to only have one solution. So this is your answer right here in radians. Now, if I wanted to convert that to degrees, because remember our homework problem input system is rather picky, I would convert that. So I've got negative 0.017498 radians. I'm just going to write radians, and I want to end up in degrees, so I'm going to convert that to degrees. So my radians are going to cancel out. So if I take negative this number here times 180 divided by pi on my calculator, not canceling out the pi here, you're going to get an angle of this very small degrees, and if you're asked to round it, then this would actually round to negative 1 degrees. All right, so this would be our answer right here. I've only got one angle that fits the bill within that interval in degrees. All right, so we're going to keep increasing in difficulty with these videos. So this is the end of this one. We're going to move on from here.